Okay, welcome again. Now let us proceed with the help of a few slides. First, I want to define a system to you. A system is defined as a combination of components that act together to perform a function not possible with any of the individual components. In the real life system, there is a lot of complexities. Nothing is too simple to be just a simple interconnection of individual components. Generally, a system is an interconnection of several subsystems, and each of the subsystem is again a combination of several individual components, and not only the components of one kind but components of different kind. For example, in an electromechanical system, there will be an electric circuit, a magnetic circuit, and some mechanical moving parts. So in the real life situations, we have to deal with systems which are far more complex than what we study in textbooks. We will see in case of some of the examples. And a control system generally is associated with a system is that means by which any quantity of interest in a system can be maintained or manipulated as desired in a desired manner. There are two types of control systems. One is called as open loop system. It is very simple. It looks as shown in this block diagram. There is a command input which goes to a reference selector, and the reference selector produces an output which acts as an input to the system, which is composed of forward elements, and these forward elements act so as to produce the desired output. The open loop systems are generally not so costly. They look simple, and the disadvantage is that they are not very accurate, and they are susceptible to noise and disturbances emanating from the system or emanating from the environmental changes. Other type of control system is a closed loop control system as shown in this block diagram. In this case, command input again goes to a reference selector, which again produces a reference input. However, the reference input is now compared with a feedback signal which is dependent on the output. So in a closed loop system, there is a provision of feeding the output back to the input side, and the output does have effect on the input. The difference between the reference input and the feedback signal, that error or actuating signal, enters the forward elements and the desired output is produced. The closed loop control systems may be costlier compared to open loop systems. They may be more complex than the open loop systems. However, they overcome the drawbacks of open loop system. They are more accurate and they are less susceptible to disturbances or noises. Define the entities in the diagram. So for example, command input, it is the motivating input signal to the system which is independent of the output and exercises control over it. It is generally required that the output should match the command input. The reference selector, or simply an input transducer, is that unit which establishes the value of the reference input. The reference selector is calibrated in terms of the desired value of the system output. And reference input is the command expressed in a form directly usable by the system. Forward element is the unit that reacts to an actuating signal to produce desired output. Essentially, this is the major part of the system. The output is that quantity that must be maintained at a prescribed value. The feedback element is the unit that provides the means for feeding back the output quantity, and the actuating signal is the signal that is the difference between the reference input and the feedback signal. If the feedback elements and the reference selector have unity gain, or which reproduce the respective quantities, like if the reference selector reproduces the command input itself and the feedback element reproduces the output itself as the feedback signal, then the input reaching the forward elements is just the difference between the desired output and the actual output, and in that case it is simply the error. However, the general terminology is the actuating signal. In control system, we are generally required to study the dynamical systems. And a dynamical system is a type of system in which the present output is dependent on the present as well as the past values of the input and output. A dynamical system can be described in two ways. One way is the input and output variable based description. This was being used till 60s in the classical control, and even today when we use the classical methods, and it is the transfer function in case of the continuous time systems. However, in 60s the state variable approach came, and in that the description of the systems is given in terms of input, state and the output variables. And this is the framework in which we will be studying control system as regards the course which we are going to do. This course will cover some topics like this. It will provide you mathematical modeling of dynamic systems from first principles and representation into the standard state space form. The solution of the state equations, basically the representation is into standard state space form consists of a state equation and an output equation. So solving the state equation will be told to you in the course. We come across a mathematical entity called as the state transition matrix, which is abbreviated as the STM. It is a very useful quantity in solving the state equations, and we will also learn about different methods of determining the state transition matrix. In classical controls, there was nothing like controllability and observability. However, these two have been introduced in the modern control, which is the subject matter of our study, based on which we will be studying. These terminologies will be introduced. The various methods of testing the controllability and observability of the system will be introduced to you in the course. Stability of the systems based on the Laplace stability analysis will be introduced. We will study control system design, such as based on the pole placement, linear quadratic regulator design, linear quadratic based control, periodic output feedback and fast output sampling feedback based control system. We will study design of observers and state estimators. Basically, we will study the Kalman filter, and we will do a number of case studies. The prerequisite to this course, if you have undergone a first course in control systems engineering, that will be very useful. However, in case you have not done it, still you may go through this course, because most of the time I will try to cover this course so as to remain independent of the basic course in control system engineering. I will try to avoid reference to the basic course in control system engineering. However, knowledge of engineering mathematics, first order differential equations, how to set up and how to solve them, elementary matrix theory, matrix operations like addition, transpose, multiplication, inverse, etc. If you know, that is good. And Laplace transform analysis, inverse Laplace transform, and algebraic manipulations with the help of partial fractions. These are some prerequisites. By undergoing this course, one will be able to analyze the system behavior, one will be able to work out improved design of control, one will be able to implement state feedback controllers based on observed or estimated states, one will be able to implement multi-rate output feedback controllers capable of achieving. By undergoing this course, one will be able to analyze the behavior of a given dynamic system, the system at hand, to work out the design of control and improve the design of control, to implement state feedback controllers based on observed or estimated states, or to implement some kind of multi-rate output feedback controllers such as the periodic output feedback or fast output sampling controllers. These controllers are capable of achieving response characteristics comparable to those based on state feedback. As a self-study topic based on whatever we have done so far, I suggest that the students should refer to the textbooks by Jean D'Azo and C.H. Hoopis, another textbook by Jean F. Franklin, David Powell and Emami Naini, or the textbook by Norman S. Nice, and prepare a short note on evolution of control systems.